Okay, so welcome to my CSCB58 file project. We'll just jump straight into the gameplay, and then I'll show you all the features for all the milestones. So, as you can see here, after running the game, we've drawn our walls, we've drawn the playing area, the play field, along with our first tetromino, so that's milestone 1. Milestone 2, as you can see, the WASD keys move it as expected, and then if I press Q, it'll quit the game. That's milestone 2. Let's just rerun that quickly. And then milestone 3, if I try to go into the walls, you can see that I can't go past them. We have our wall collision. Then once I land on the floor, it'll lock in place and then spawn a new tetromino. And then there's also tetromino collision, so I can land on other pieces like that. And then once I get a full row, we'll just try and fill up this row quickly. Once this row fills up, you'll see that gets cleared. There we go. So that is milestone 3. For milestones 4 and 5, as you can probably see by now, I've implemented the full set of tetrominos. That's one feature. And then I've also implemented different colors per tetromino type. So for example, this L type here, they're all going to be orange. This I type is always going to be blue, so that's another feature. Another feature you've probably noticed is if I stop putting any inputs in, every second it'll just drop on its own, so we've implemented gravity. That's another one. And then if I want to pause the game, just press P. There we go, it stops moving. None of my inputs are moving it until I press P again to unpause it. And then another feature you can see I've implemented is the score. So every time I clear a line, the score gets implemented by 1. So you can see it here. There we go. And then I'll actually just quickly try and clear 2 rows at a time to demonstrate that that works as well for the scoring. Okay, well, we're not getting any good pieces for that. Okay, here we go. We're actually about to clear 3 rows, so it should increment by 3. There we go. And then my last feature, if I just fill up to the top, there we go, we have our game over screen. And then if I press R, we start an entirely new game. The score is reset and the play field is reset. So yeah, that is the gameplay, that's all the features. We'll just move on to the design brief. Okay, so this is the design brief. As you just saw, these are the extra features that I implemented. For memory layout, this is pretty self-explanatory, so for the sake of time, I'm going to have to skip that and go straight to data structures. But for data structures, basically everything that you saw drawn was drawn from these bitmaps, which are basically just like binary images, which store the actual shape of the pieces, the text, and also the digits for the score. So basically, when we want to draw these, the program just loops over the bitmap, and whenever it's equal to 1, it'll find its location on the display and paint it there. And then numbers, tetrominos, and colors. These are basically just arrays to easily access the current digits and the current piece to display. And for example, you can use these mutable variables, shape and orientation, as indices for tetrominos to actually get the bitmap for the current piece. Same with numbers, you can use score 10s and score 1s as indices for those. And then to get the current color, you just use shape as an index for that array. So then we also have our playfield array, which is basically just a really large array that stores all of our locked pieces. So if it's equal to 0, that means there's no piece there. But if it's non-zero, then that value at that location is actually the color of the current piece that's there, which makes it really easy to just redraw the playfield when we need it. And then our key routines for drawing, we have our main drawing functions here. And then to optimize it a little bit, whenever something moves, we only actually redraw the changed area. So for example, when the tetromino moves, instead of redrawing the entire background and the playfield, we'll just erase the previous position and then draw the new one. This kind of speeds it up a bit and also just reduces the flickering on the screen. That's the same for the score as well. For input polling, this happens every 10 milliseconds. Basically, what's happening is it'll check for an input. If there is an input, it'll handle it accordingly. If there's no input, or if it's not one of these ones, then it'll just sleep for 10 milliseconds, and then it actually keeps track of how many times it slept for. So once it reaches 1 second, that's when you're going to apply gravity to just drop the piece down by 1. So then we also have collision detection. So we have our two main functions here. Check game over is called right after spawning a new Tetramino, and that just handles the game over condition. While check collision is called whenever the piece moves or rotates from either gravity or one of the inputs, and then it handles that collision accordingly. It also handles our clearing of the full rows after a piece lands. And then this is just the general flow of the entire game. So of course, after initialization, you're going to spawn the Tetramino, and then immediately you're going to check if the game over condition is satisfied. If it's not game over, you're going to continue as usual. You're going to save the current position, and then handle any inputs, or just apply gravity if there is no input. And then once that piece moves, you're going to check and handle any collisions, and then redraw the new position. And this is basically the main flow of the game that just keeps repeating. And yeah, that's basically the entire project. Thank you.